Today we are going to be talking about stainless steel. Stainless steel is a corrosion-resistant alloy of iron with a minimum of 10.5% chromium. It is often containing other elements like nickel and molybdenum. It is also known for its resistance to rusting and staining. Here we have some stainless right here. Stainless steel often requires lower welding amperage compared to steel and aluminum because it is a poor thermal conductor. Right here we also have the steel and we have aluminum. This means the heat stays localized, requiring less energy to achieve a weld. This means that it is easier to control the weld puddle with low amps since the heat stays localized. So here on the stainless, you can see all the heat is in one spot right there. You can see it on the top plate and then on the bottom plate right there. It all generally stays in the same area, really close to the weld puddle. And then on steel, you can see the color changes up here and a little bit further away from where the actual weld was made. Stainless steel is classified mainly into three families. Austenitic being one of them. Its properties are non-magnetic, high corrosion resistance, good ductility, and weldability. And its applications would be food processing, chemical processing, architectural applications, and aerospace. The second family would be ferritic. Its properties include magnetic, good corrosion resistance, lower cost than austenitic grades, lower ductility, and weldability. Its applications that it would be used for would be automotive exhaust systems, water tanks, and heat exchangers. The third family would be martensitic. Its properties are magnetic, good hardness and strength, lower corrosion resistance compared to austenitic and ferritic grades, and its applications would be used with knives, scissors, razors, and medial tools.
Some base metal classifications of stainless steel include 304L, 303, and 309. 309L can be welded using 308, 309, 310, and 317 filler wire. 303 can be welded with 308, 309, 310, 312, and 315 filler rod. 309 can be welded by 308, 309, 310, 312, 316, and 317 filler rod.
And right here is the stainless steel chart. Right here we have the base metals. There's 303 right there. It could be welding using 310, 309, 312, 308, 315 filler wire. There's the 304 base metal, 310, 309, 312, 308, 308L filler wire. And then right there is the 309. It could be welded using 310, 39, 312, 308, 317, 16. What is carbide precipitation? Carbide precipitation is the formation of carbon compounds, also known as carbide, within a metal, particularly along grain boundaries. Okay, so that's how we have them right here in the blue. If this occurs particularly in stainless steel, and it is when it is heated up to specific temperatures, this process can lead to a loss of corrosion resistance and mechanical properties. So right there we have the chromium carbide precipitation, and then in the red we have the chromium depletion region. The chromium depletion region is an area near the green boundaries where the concentration of chromium is reduced, making it more susceptible to corrosion. This occurs when chromium carbide precipitates to the green boundaries during precipitation or high temperature explosion. So all this occurs whenever the stainless steel that you're welding on is getting too hot, overheated, and it'll affect the grain structure. Elijah, what are you doing, man?
Just got done welding this. Is it good or not?
What do you mean, is it good? You got a whole bunch of carbide precipitation in there.
What is that?
You don't know what that is? I got you. You can tell you have carbide precipitation due to the gray color you have in the heat affected zone and in the weld itself. This coloration is a sign of carbide precipitation has occurred and that the corrosion resistance of the weld area has been compromised. So it has to look more or less like this. It has to be colorful. We want a more like of a straw color like we have in the beginning right here. If we get this, then you're getting carbide precipitation in your weld.
Hey Sebastian, what are you doing?
I just got finished welding this stainless T-joint, but I'm getting carbide precipitation in there. But I know the basics of it, but I don't know like how it affects the weld or why it's bad at all.
I'll tell you how it affects the weld. Carbide precipitation causes chromium and carbon to migrate to grain boundaries and form chromium carbides, weakening the structure of the weld, causing corrosion in the weld area. The formation of chromium carbides at the grain boundaries make the weld more sustainable to cracking, especially under stress or during thermal cycles.
Elijah, I see that you don't have any carbide precipitation in your TIG weld. How did you do that? Because I'm getting a whole bunch in mine.
Yeah, carbide precipitation is prevented by inner pass cooling. Make sure you let your metal cool before you run another pass. I like to use chill blocks so it takes a lot of the heat away from the stainless steel. Also, you can use post-weld heat treatment to dissolve any carbide.
Hey Elijah, I got a question.
Yeah, what is it?
What is stainless passivation?
Stainless steel passivation is a chemical treatment that improves resistance to corrosion by eliminating surface iron, unlike the natural oxide layer. Passivation quickly forms a protective chromium oxide film, recommended in environments with harsh chemicals or humidity.
Elijah, I had a question.
What is it?
What's post-weld pickling?
Post-weld pickling is a chemical treatment process for the removal of scales, such as oxides from stainless steel, by immersion in a liquid containing sulfuric acid or hydrochloric acid.
Elijah, what are some techniques for weld pickling and passivation?
Some techniques are gel application. Apply paste or gel manually on the surface, useful for spot treatments of weld and intricate areas. Dip pickling is another way. It involves dipping the whole piece into a bath with pickling fluid. This method is effective when narrow areas and corners which are difficult to reach manually. Here's dip pickling. You dip the whole piece into the acid. Also, you spray application. Spray the acid solution onto a surface, sustainable for a site treatment.
Elijah, what are some advantages of pickling?
Some advantages of pickling are it removes dirt, grease, oil, and oxides. It assists in the formation of new chromium oxide layer, helps to regain corrosion resistance.
All right, but what about passivation? What are some advantages of that?
Advantages of passivation are it increases thickness of the chromium layer, forms a protective layer that does not easily interact with the environment. It reduces the need for maintenance.